So in this example, we are given with a probability distribution. Okay, so here we have our table with the variable x. So this is our discrete random variable. X takes a number 0, 1, 2, and we do have the probability that x takes this number. Okay, the probability that x takes a number 2 is 1/3. In the similar way, the probability that x takes number 1 is 1/3, and the probability that x takes a number 0 is also 1/3. And the very first question is find mu. Now what does mu for us? So what is this mu? What does it mean? It is the mean or expected value of this probability distribution. So let's go ahead and calculate the mean or expected value of this probability distribution. So for part A we have mu. So mu is mean, okay, which is also the expected value of our discrete random variable x. And the formula to calculate this expected value or mean is summation of x times p of x. And this is, so we take each value of x and multiply by its probability. So let's take x equals to 0. So 0 times the associated probability is 1/3, plus let's take another value of x, which is 1. 1 times the probability 1/3, plus let's take another value of x, which is 2 times the probability is 1/3. So this is 0 times 1/3 is 0, plus 1 times 1/3 is 1/3, plus 2 times 1/3 is 2/3, and this is equals to 3/3, and we have 1. So 1 is the mean for this probability distribution. Okay, 1 is the expected value of this distribution. Now here we have this numerical value. Is this our mu parameter or statistic? It is. Mu is parameter. Mu always tells is the number used to describe the population. Okay, so this mu is our parameter. Okay, so this is what we have done, like calculating expected value a lot. Okay, now let's go to the part B. For a random sample of n equals to 3 observations from this distribution, find the sampling distribution of the sample mean. Now we know our x takes a value 0, 1, 2, 3. Okay, does anyone have any question on this one? Okay, so for part B, so we know from the probability distribution that our x takes a value 0, 1, 2. Okay, now we have to make a sample of 3 observation. Okay, so from the distribution we know x takes 0, 1, 2. Okay, now we need to make a sample. Okay, so sample of 3 observation means we need to make a sample, the possible sample from these 3 number. Now let's take our first sample is that we can observe, we can get 0. Okay, so let me write down sample. Now we will make a list of every possible sample from this 0, 1, 2. Okay, now we might get a sample that we see 0 first, 0 second, 0 third, right? So this is like you have a box filled with a 0, 1, 2 number, okay, and you are picking 3 times. Okay, so we might get 0 first, we might get 0 second, and we might get 0 third. Now what would be the next sample? So we might get 0 first, right, 0 second, and 1 third. So this is our next sample. So we are creating the possible sample from this list 0, 1, 2. Okay, so next we might get a sample 0, 0, 2, right? So this can be also a sample. So we are using these 3 number, okay, 0, 1, and 2. So we are using these 3 number to create a sample, the possible sample, and we will make a list of every possible sample. Okay, what would be the next one? 0, 1, 0, right? So this is the next So let me, then the next would be 0 1 1 0 2 0 0 2 2. Then we can have 0 0 2. Oh yeah. So let's see what we have next.
0 1 2.
Or 0 1 2. Okay, that's the one. Or also, so we started 0. Now let me put 1 at first. Okay, so we might get 1 first, 0 second, 0 third. We might get 1 first, 0 second, 1 third, 1 0 2, right? So the next we might get 1 first, 1 second, 0 1 1 1 1 1 2. I think we are done with. Okay, so we have 1 0 1 1. Now let's use 1 2 1 2 0 1 2 1 1 2 2. So I think we are done with 1. Now let's start 2 first. So 2 0 0 2 0 1 2 0 2 2. Okay, 1 0 2 1 1 2 1 2, then 2 2 0 2 2 1 2 2 2. Okay, so okay, so these are the possible sample that we can create from these 1 2 3. Okay, now for each sample, since we are since we are interested in are you still writing this sample? Are you done with making a list of this sample? Okay, now since we are interested in creating a sampling distribution of mean, okay, so we want a sampling distribution of mean. So let's find mean of each sample. Okay, so let's go ahead and find mean of each sample. So we have x bar. Okay, so finding mean is you add all number and we are dividing by 3, right? Since we have a 3 sample here, so this is 0, so 1 divided by 3. Let me use the fraction 1 over 3. This is 2 over 3, this is 1 over 3, this is 2 over 3, this is 2 over 3, this is 4 over 3, this is 1 over 3, this is 2 over 3, this is 3 over 3, which is 1, this is 2 over 3, this is 3 over 3, which is 1, this is 4 over 3, this is 1, 3 4 over 3, 4 5 5 over 3, 2 over 3, 1, 4 over 3, this is 1, 4 over 3, 5 over 3, 4 over 3, 5 over 3, and 2. Okay, so we find mean for each sample. If you are asked to draw sampling distribution of median, then you are finding the median of each sample. Okay, now let's find the probability of getting each sample. Okay, now we will find the probability that we get 0 0 0. Now, so let's find the probability for each sample. So from the table, what do we know? The probability that x takes a value 0 is 1/3, right? Now, we are interested in finding the probability that we have 0 and 0 and 0. Okay, So we have an intersection and intersection. So we multiply probability of 0 times probability of 0 times probability of 0. And what is that? So we have 1/3 times 1/3 times 1/3, and that is 1 over 27. 1 over 27. 1 over 27. Okay. Now probability of 0 times probability of 0 times probability of 1. Okay.
They're all 1 over 27.
It's going to be all 1 over 27. Do you all agree? Because each, see, the probability of 0 is also 1/3, probability of 1 is also 1/3, and probability of getting 2 is also 1/3. So we have, so if we multiply, so we always get 1 over 27. So 1 over 27, 1 over 27, 1 over 27, 1 over 27, 1 over 27. So for each sample, the probability of getting each sample is 1 over 27. One over 27, 1 over 27, 1 over 27, 1 over 27. And just let me take one sample and show you in detail, okay, how we got this, just in case. So let me take this sample. So we are finding probability that we get 1, 0, 1, and this probability of 1 times probability of 0 times probability of 1. From the table, this is 1/3 times probability of 0 is 1/3 times probability of 1 is 1/3, and we get 1 over 27. In the similar way, we have 1 over 27 for each sample. Okay, any question up to here? Okay, now we are not done with part B. Okay, we are creating a sampling distribution of mean. Okay, so we want a sampling distribution, means, so what does our sampling distribution looks like? So it is a table, right? So we are creating a table. Now what will be our variable? So what variable are we using here? So we are creating a sampling distribution of mean, right? So our mean will be the variable x bar, okay? And we want probability of x bar. Now we make a list of every possible value of x bar. Now let's start. So what is the what are the x bar values here? So we have this 27 different x bar, right? Not all are not different. So what is the, okay, so we have 0, right? So x bar is 0. X bar is 1/3, right? X bar is also 2/3. We do have 2/3. We do have x bar equals to 1. We do have 4 over 3 x bar. We do have 5 over 3. And the last one is 2. So these are the different values for x bar, okay? So this is what we have for our x bar. Now we find the probability that x bar is equals to 0, okay? Now any question here? Okay, now let's see, let's look for the x bar with a value 0. So we have only one x bar, 0, right? Do we have any more x bar equals to 0? No. So its corresponding probability is 1 over 27. So p of x bar when is equals to 0 is 1 over 27. Now let's look at the x bar value equals to 1/3. Okay, 1/3. Okay, let's see. So we have 1/3 here. So this is also 1/3. This is also 1/3. Okay, yes. So this is, so we are looking for the probability that x bar is this 1/3, okay, or this 1/3, or this here. So you add each probability, 1/27 plus 1/27 plus 1/27, and that give us 3/27. Now we look for 2/3. So we have 2/3 here, 2/3, 2/3, 2/3, 2/3, 2/3. So how many would we have? 1, 2, 3, 4, 5, 6. Says 6/27. So you are adding each probability. Now let's look at x bar equals to 1. So we have 1 here. So we have 1 here. We have 1 here. We have 1 here. We have 1 here. So how many 1 do we have? 1, 2, 3, 4. Or do we have more? Okay. So this is 1, 2, 3, 4, 5. So it is 5/27. Now 4/3. So 4/3 is here, 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 4/3 is here. So how many do we have? Okay, 1, 2, 3, 4, 5, 6. 6/27. Now we are interested in finding the probability that x bar is 5/3. So 5/3 is here, 5/3 is here, 5/3 is here. Okay, we have 3. So it is 3/27. Now for 2 we have 1/27. Did we miss any here? And we know how to check this distribution, right? So how do we know this distribution is correct? We add each probability and sum has to be equals to 1. Now let's check that. So 1 plus 3, 4 plus 6, 10 plus 5, 15, 15 plus 6, 21 plus 3, 24 plus 1, 25. So we are missing 2. So let's find out. Okay, what did we miss here? Or did we miss any sample?
Yeah, there's only 25 samples.
Okay, so there is only 25 sample. So what sample did we miss? So let me check my list. So 222, 221, 220, 212, 211, 210, 202, 201, 200. Then we have 122, 121, 120, then 112. Okay, then we have 1, 110, 102, 101, 100, 0, 2, 2.
Need 2 more zeros starting soon.
Okay, 0, 2, 1. Okay, so here okay, so let me add one more sample. So we have 0, 2, 0. So we have 0, 2, 1. And what will be the mean? So 3, the mean would be 1, right? So mean is 1 and the probability is same, 1/27. So now let's see what is the next here.
Aren't you also missing 0, 1, 2?
0, 1, 2. Okay, 0, 1. Okay, 0, 1, 2. So the mean is 1 and the probability is 1 over 27. So I want you to add these two samples. And on your exam, you won't have 3 observation, okay? The maximum would be like 2 observation will be given to you. So you won't need to spend this much time. So it means we added, so 1, 1 twice. So our here, so the probability that x bar is equals to 1 is 7 over 27. 7 over 27. 6, 7, 6. Yes. Now once we add each probability, the sum is equals to 1. Okay. So this is the distribution for part B. Okay. So this is our sampling distribution of mean. Any question? And you will have very similar example on your exam. Okay. But you won't have 3 observation. It will be 2 number. Okay. Okay, now let's go to the next one here for part C. Find the sampling distribution of the median of a sample of an observation from this population. Now, so for the median, so I want you to do this by yourself. So what do we need? So we need a median. So I want you to find the median of each sample, and you all know how to find the median, right? Now, once you have the median, you make a table. Okay, so your table, so this is for part C, we'll have a median value, and you must find the probability that your median takes the numbers. And we don't know what our medians are, and I want you to find that. Okay, so this is for you. Can you do this part C, in the similar way like we did part B? Okay, now, so we can just finish. Okay, now let's see. So what is the median for this 3 sample? 0, right? The median for this second sample is 0. We are looking for the middle number, right? Okay, so this is also 0. This is 1. This is 1. So this also has 1. Okay, this has 2. This has 2. This is
Doesn't the median have to be put in?
ascending order. Thank you. Yes. Now, okay. So if that is the case, so yeah. So this won't be correct, right? Let me correct. Okay. So up to here.
The 0, 1, 0 would still be 0.
0, 1. Okay. Thank you. So this one is still 0. Yeah, we have to arrange the data in ascending or descending order. Okay, so up to here is correct, right? Now we have 0, 0, 2. So the middle number is 0. Then we have 0, 1, 2. So middle number is 1. So we have 0, 2, 2. So it's 2. So 0, 0, 1. 0, 0, 1, 1. 1. 0, 1, 2. 1. 0, 1, 1. So that is 1, 1, 1. 1. That's 1. 0, 1, 2. That is 1. 1, 1, 2. That is 1. 1, 2, 2. That is 2. 0, 0, 2. That is 0. 0, 1, 2. 1. 0, 2, 2. 2. 0, 1, 2. 1. 1, 1, 2. 1. 1, 2, 2. 2, 0, 2, 2, 2, 1, 2, 2, 2, 2, 2, 2, 2. Any question finding the median? You are looking for the middle number, but make sure you are arranging in descending or ascending order. Okay, now what are the possible values of median? So median is 0, right? Median is 1, and median is 2. These are the 3 values that we have for median, right? Now, how many 0 median we have here? Let's go ahead and count. So we have 1, 2, 3, 4, 5, 6, 7. So that is 7 over 27. So we have 7 over 27. How many 1 do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, 13 over 27. Now let's count 2. 1, 2, 3, 4, 5, 6, 7. Okay, we have 7 over 27. Now let's double check. Is the sum equals to 27? Sorry, 1. The probability has to be equals to 1. 7 plus, that's, yes, the probability sum is 1. So this is our sampling distribution of median. Any question? Now let's go to the part D. So in part D, okay, using part B and C, so that both the mean and median are unbiased estimator of mu for this population. Okay, now we have these two sampling distribution, and we have to show these two sampling distribution are unbiased estimator of mu. Now, how do we know this? How do we know a sampling distribution is unbiased? To be unbiased, the mean of a population has to be equals to mean of these two sampling distribution. Now we find mean of this sampling distribution, okay, and if the mean of this table is equals to mu, we know our mu, which is our mu is 1, okay. If we end up getting mu equals to 1, then the x bar is a unbiased estimator. In the similar way, we find the mu for this sampling distribution, okay. So let's go ahead and find mu for our sampling distribution of mean. So mu of x bar, okay. So this is sampling, so this is mean of a sampling distribution of this table, okay. So let me write down this. So this is our mu is mean or expected value. So this is mean of sampling distribution of mean. So we are finding the mean for this sampling distribution of mean, okay. So the formula is summation of our variable is x bar, okay. So this table has a variable x bar, so summation of x bar times the probability of x bar. Now we take each value of x bar, multiply by its probability. So x bar is 0, so 0 times 1 over 27 plus, let's take another value of x bar, 1/3. 1/3 time probability 3 over 27, 3 over 27 plus another value of x bar, 2/3. So 2/3 times, what is the probability? 6 over 27 plus 1 time probability 7 over 27 plus, let's take another value of x, 4 over 3. 4 over 3 times the probability 6 over 27 plus and another value of x bar is 5 over 3 times the probability 3 over 27 plus, and the last value of x bar is 2 times corresponding probability 1 over 27. So the first one is 0 plus 3 over 3 times 27. What is 3 times 27? Is it Is it not 91? Is it 71? 81? Okay. Okay. 81 plus 2 times 6. 12 over 81 plus 7 over 27. And let's make this 81, okay, so that we could add easily. So times 3 times 3 plus 4 times 6, 24 over 81 plus 5 times 3, 15 over 81 plus 2 over 27. Let's make it 81. Now what is the sum here? So 3 plus 15 plus 21, that is 16, 26, 36 plus 36 for 40, 60, 75 plus 6, 81 divided by 81, we have 1. Okay, now which is equals to our mu, right? So mu is the mean of a population, and if the mean of a sampling distribution is equals to mean of a population, what do we call those statistics? Those are unbiased estimator. Our x bar is unbiased estimator. So mu of x bar is equals to mu, and this conclude that x bar is unbiased estimator. Now in the similar way, we are asked to show that sampling distribution of median is also unbiased estimator. And how do we do that? We use the similar method. Okay, now we find mean of our sampling distribution of median. So the next we find mu of m, and this is mean of sampling distribution of m, which is median. Okay, and this is, how do we rewrite the formula? It would be summation of, what is our variable? M times P of m. So we take each value of m, multiply by its probability, and take a sum. Okay, so the first value of m is 0 times the probability is 7/27 plus second value of m is 1 times the probability is 13/27 plus the last value of m is 2 times the probability is 7/27. So this is 0 plus 13/27 plus 2 times 7, 14/27, and this is equals to 1, and which is mu. Okay, so mu of m is equals to mu. It means m is also unbiased estimator. Okay, to be unbiased estimator, the mean of a sampling distribution has to be equals to the mean of a population. Okay, now can you do part E? Find the variance of a sampling distribution of the sample mean and the sample median. Now for these two sampling distribution, we find the variance, we find the standard deviation. Okay, and at the end we have, for number F, we have to make a decision here to pick the best estimator. Okay, now, okay, does anyone have any question up to here? Finding the or proving that our statistic are best estimator, sorry, unbiased estimator. Now let's find the standard deviation for each of these sampling distribution. Okay, so let's find sigma. Okay, let's find variance for a sampling distribution of x bar. So this is variance of sampling distribution of x bar. And what is the formula? The formula would be summation of, what is our variable? X bar minus mean. So what do we call the mean of a sampling distribution of x bar? Which is mu of x bar squared times the P of x bar. So now we take each value of x bar, find the difference with our mu of x bar, which is 1, square it and multiply by the probability. So let's take, so our x bar is 0, so let's substitute 0 for x bar minus, what is mu of x bar? 1 square times the corresponding probability is 1/27 plus, let's take another value of x bar, which is 1/3 minus mu of x bar is 1 square times the probability 3 over 27 plus, let's take another value of x bar, that is 2 over 3 minus mu of x bar 1, you square it, multiply by its probability, which is 6 over 27 plus, let's take another value of x bar, that is 1 minus 1 square times the probability, 7 over 27 plus another value of x bar is 4 over 3 minus mu of x bar, which is 1, square it and multiply by its probability, 6 over 27 plus the next value of x bar is 5 over 3 minus 1 square times the probability, 3 over 27 plus 2 minus 1 square times the probability, 1 over 27. And I want a final answer from you. Okay, let's see. Can anyone help me here? How much we get?
I got 2 over 9.
2 over 9. Okay, 2 over 9. Now the standard deviation sigma of x bar is square root of 2 over 9,
0.4714.
0.4714. Okay. Now, so this is for you. Now I want you to calculate sigma square of m and sigma of m. Okay. And if you need help, let me know. You will have a very similar example. Okay, you will be given a sampling distribution. You will be asked to verify that statistic is unbiased estimator. Okay, you will be asked to find the standard deviation for this sampling distribution. And if you need help, just let me know. And if you have something different than 2 over 9, let me know. Okay. And those, if you have completed this, I want you to do, okay. We'll start section 6.3 once we complete this one. Okay, so let me, or does anyone have any answer different than 2 over 9? You have 2 over 9. Okay, so I'll take this answer. Now, in order to find the sigma square of m, and what does this mean for us? This is the variance of, what is this? Variance of sampling distribution of median, okay, of m. And the formula is summation. So you will be given a general formula, okay, on your exam. So you won't have this specific formula. So you have to be able to rewrite this formula. So the formula is median minus mu of distribution, that is mu of m square times p of m. So let's take each value of m. So m is 0 minus mu of m is 1 square times, what is the probability? 7 over 27 plus 1 minus 1 square times the probability is 13 over 27 plus the last value of m is 2 minus mean, which is 1 square times the probability is 14 over 27. And what do you have final answer for this one? Julia, do you have this right?
The sigma squared or
Sigma square.
14 over 27.
14 over 27. And what is the sigma of m, the square root of this?
0.7201.
0.7201. So we have the standard deviation for each sampling distribution. Now, out of these two sampling distribution, which statistic is our best estimator? That is part F. Okay, now for F, so from E, which estimator would you use to estimate mu? Do you use X bar to estimate mu, or do you use median to estimate mu? Which one do we use here? X bar. And why X bar is the best?
And the least variance.
It is unbiased estimator and is a least and has a least variance. Okay, we always pick the statistic which is unbiased and has a least variance. So X bar is our best estimator here. Okay, does anyone have any question? Okay, now we'll start our section 6.3 tomorrow, but right now we still have like 8 more minutes, and I want you to start number 9, and if you complete 9, I want you to do number 10 from your review handout. Okay, and if you need help, I'll help you.